Welcome to video 8. Today we're going to be looking at more quadratic linear systems algebraically, solving just like what you did in yesterday's video. So let's go through those steps together. So the first thing that you need to do is make sure that both equations are in y equals. So if I look, my first one here, y equals x squared plus 2x plus 2, that one is ready to go. The next one, y plus 2x equals negative 2, is not in y equals yet. So what's on the wrong side? The 2x is with the y. I want y alone. So the first step is to subtract the 2x to both sides so that I then have the equation in y equals. Okay, so now that I have this into y equals, since they're both y equals, we can make them equal to each other. So it'll be the x squared plus 2x plus 2 equals the negative 2x minus 2. And we could write that either way, having the x squared plus 2x plus 2 on the left or the right. So now I see we want to keep the a value, or the coefficient with the x squared. We want to keep that positive. So right now, since it's a positive x squared, I'm going to leave that one on the left-hand side, and I'm going to move the 2x and the 2 to the other side by doing inverse operations. So that means I'm going to add the 2x and the 2 to both sides. When I combine like terms, I end up with the x squared plus 4x plus 4 equals 0. Now I'm ready to solve this quadratic. So we have the three options really, either completing the square, quadratic formula, or factoring. Since in the last video we did a lot of factoring, I'm going to review using the quadratic formula for this question so that you see that as well. So that's our option here, and I'm going to start by identifying A, B, and C. So our A value is 1, B is 4, and C is 4. Then we can pull out our reference sheet, because remember the quadratic formula is given to you. You don't have to memorize it. And look at that quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. Then I'm going to sub in my A, B, and C values in place of the A, B, and C in the formula. So give that a try and see if yours matches mine. So I end up with x equals negative 4 plus minus square root parentheses 4 close parentheses squared minus 4 parentheses 1 close parentheses 4 close parentheses all over 2 parentheses 1 close parentheses. So all those parentheses, remember, are used whenever we sub in values. Now what we can do is simplify each piece. So a negative 4 is negative 4. Then plus minus, and remember we simplify everything under the radical by putting it in the calculator, but not the square root sign just yet, just all those numbers underneath. When we do that, we end up with 0 under the radical. So I'm going to write that as, and then the denominator, 2 times 1 is 2. So now I can take the square root of 0 in the calculator and it becomes just 0. So now I'm going to rewrite this as, and that's negative 4 plus minus 0 divided by 2. Now, negative 4 plus 0 and negative 4 minus 0 are both going to give me the same answer of just negative 4. So x equals negative 4 over 2. And negative 4 divided by 2 is negative 2. So my x value is negative 2. I only ended up with one x value, and it was because when we would have split this into the two answers, and I'll write it off to the side so you kind of see. And I'm actually writing, because this is optional, you don't have to have this on here. So the negative 4 plus 0 over 2 and negative 4 minus 0 divided by 2. If I would have done that, then I would have gotten negative 4 plus 0 is negative 4 divided by 2 would have given me negative 2. And then for the other one, negative 4 minus 0 is still negative 4 divided by 2 ends up giving me the same answer of an x value of negative 2. So that's why I didn't bother writing both out, but you could write both out this way if you'd like. Well, then I have the same x value, so now that I know what the x is, we can sub it in place of x in the equation. Obviously, it's easier to substitute into this because I don't have a degree of 2. It's just plug in for x, and I don't have to worry about parentheses or squaring the right thing or anything like that. So rewrite this linear function, plugging in negative 2 in place of x. So then I have this y plus 2x equals negative 2. That's the equation I'm using, the original that was given to me, subbing in that x value of negative 2. So y plus 2 times negative 2 equals negative 2. Simplify 2 times negative 2 to become this y minus 4 equals negative 2. And then to get y by itself, we need to add 4 to both sides. And then negative 2 plus 4 gives me y equals 2. So that's my y value. I only had to sub in 1 because, again, it was a unique situation where I only had one x value as an answer. So my solution then is the coordinate point -2, 2. And remember that we are talking about a quadratic and a linear function, so it's a point or 2 points of intersection when we write it as a solution. So that's why it's an x comma y in parentheses. Okay, let's try another one. So the first step is to check to make sure that it is y equals, and the first one, y equals x squared plus x minus 9 is good, and the second one, y equals x minus 5, that one's also good. So now we can move on to the next step. Substitute the linear function in place of y in the quadratic. So I'm going to rewrite this as x minus 5 equals x squared plus x minus 9. The next step is to get them to be, since it's a quadratic, I need it equal to 0 in order to solve. So we like that the a value is already positive here, so I'm going to move the x and the -5 over to this side so that I can keep my a value positive. So do that by subtracting x and adding 5 to both sides. Then I end up with 0 equals x squared minus 4. Now I need to solve this quadratic, so again, same options. I'm going to use factoring this time, and that's because I can see that I have an x squared and a 4 and subtraction between them. That tells me this is a difference of two perfect squares. So for a difference of two perfect squares, remember that you could use the x in the box to factor this, but I don't have to. I can use that difference of two perfect squares. So that's the shortcut where we open up two sets of parentheses, and then one gets a plus, one gets a minus, and then take the square root of each of the terms. So the square root of x squared, and that's an x, so that goes, since the x squared is first in the original here, then x goes in the first part for each of these. And then again, remember showing the square root only over the 4 because the subtraction is what tells us we can do difference of two perfect squares. It can't be under the radical. So the square root of 4 then is 2, and then it shows us that the factors are x plus 2 and x minus 2. Now I just set each of these two factors equal to 0 because remember if either one is 0, then the product will become 0. So this is where we're going to set up our t-chart. So x plus 2 equals 0, x minus 2 equals 0, then solve them by doing the opposite in each one. So on the left here, x plus 2, I'm going to subtract 2 from both sides. And that gives me my first answer, x equals -2. Then on the right side, I'm going to add 2 to both sides. And that gives me my second x value of 2. Now, just like Mrs. Crayer said in the last video, you have to be very careful to continue the problem. Once you have found these x values, that's only half the work. Now we need to find what the y values are, because remember when it asks where these intersect, it's looking for points of intersection. So we need x, y values to show the intersections. So for my first x value, we're going to take that, I'm going to go back to my linear function, y equals x minus 5. I'm going to plug in the -2 to get out my first y value. So start by writing down the equation, the original. And then under that, I'm going to write the -2 in place of the x value. Since everything is on the right side there, I can just do -2 minus 5, either in my calculator or in my head. -2 minus 5 is -7. So that's my first y value. So that gives me one of the solutions, but I'm not done yet. I need to do the same thing now for the other x value, the x value of 2. So far, all I know is that one of my solutions is -2, -7. Now I need to do the same thing to find the other solution. So again, using my parentheses to sub in, the second x value was 2. Then I have 2 minus 5 gives me a y value of -3. So that tells me that my second solution is 2, -3. Now remember, you can check these answers by putting them into y equals in your calculator. And I should have gone over that with the previous example. So you can plug in the y equals. For this one, we would plug in the x squared plus x minus 9 in y1, and then the x minus 5 in y2. And then you can check the table of values or trace the intersection to make sure that they do indeed intersect at -2, -7, and 2, -3. So just to show you how to do that with the previous example, I should have gone over that. When we had these equations, to check this one in your calculator, you would put y equals x squared plus 2x plus 2 in y1, and then we would put the y equals -2x minus 2, the second equation here, because we had to get it in y equals before we could put it into the calculator. So the -2x minus 2 would go in y2. And then again, check the table or trace the intersection. And you'll see that there's only one solution for that one. Now, this last one, we're going to go over solving graphically just as a review topic here. So you've already done this. This one is graphically instead of using an algebraic like we did in the previous two examples. So in order to graph, I'm going to talk about the quadratic first. So when I graph this quadratic, it's in y equals, so we can go ahead and use the x squared plus 2x plus 2, but to make sure that I have the right points, we need to start by finding the axis of symmetry. So remember, the axis of symmetry formula is x equals negative b over 2a. So then I need to identify a, b, and c. So I just write down a equals 1, b equals 2, and c equals 2. Now fill in the a and b into the axis of symmetry formula. So then x equals negative 2 over 2 times 1. So negative 2 is just negative 2. 2 times 1 is 2. And then negative 2 divided by 2 is negative 1. You can also just put the fraction with parentheses the way you see it into your calculator, and especially if you know how to put those in your calculator as a fraction to get your answer of negative 1. So this in-between step you may not have. Once I found this, that tells me that negative 1 needs to go in the middle of my table. Then I need to go back 3, so from negative 1 it's going to go to negative 2, and then negative 3, and negative 4. Those are the 3 back, and then go forward 3, so negative 1, then it would be 0, and then 1, and then 2. So now that I have my x values, we can just go to our calculator, put in y equals x squared plus 2x plus 2, and then hit second graph to look at the table of values. Go to an x value of negative 4, and then the table will tell you what the output is. So negative 4 should be with 10, and then hopefully all of yours match my outputs. So I have the 5, 2, 1, 2, 5, and 10. Now this part shows me, since I have this symmetry on both sides, I probably did everything correctly and have the right part of my parabola shown since I have the symmetry on both sides. If not, then you might need to go back and check the work that you used to find your axis of symmetry. Now we can go ahead and plot these points on the graph. So hopefully your graph looks something like mine with all of your points plotted on the graph just from your table. Once you have all the points plotted, connect with a smooth curve to show that it's the parabola shape. And then the other thing I'm going to do once I've connected is make sure that we put a label on our graph so I know which one we just put on the graph. So I graphed the quadratic, so y equals x squared plus 2x plus 2. Make sure that you also have that. So the key points to remember when you graph quadratics, you have to find the axis of symmetry. Then you must show a table of values. Otherwise, that you don't have any work to show how you graphed the quadratic. Okay, the next thing we need to do is graph the linear function. So y plus 2x minus 2, but it's not in y equals yet. So the first thing I need to do is write down my equation, y plus 2x equals negative 2, and then do inverse operations to get y by itself. So I subtracted the 2x from both sides to end up with a y equals, we combine like terms, but the negative 2x and the negative 2 are not like terms, so I just have to write them side by side. Negative 2x minus 2. Now you can either put this in y equals and get a table of values, or we can use the slope y-intercept. I'm going to use the slope and the y-intercept just so I don't have to write down another table of values, but if you want to use the table, that's fine. Just make sure that you show the table of values on your paper then. So now I have the slope is negative 2 over 1 and the y-intercept is negative 2. So we start by plotting the y-intercept. So put a point at the y-intercept of down 2, and then we can use our slope to find other points by going up to left 1 or down to right 1. So when I plotted, I just continued until I could plot no more points. So I just started at that down 2 and then continued the slope all the way till I went off the graph. Now that I have all these points, I need to connect them with a straight edge and then put a label on there so I know what that graph is. And I labeled with the original y plus 2x equals -2. Now, all this work is beautiful, but I'm still not done because I didn't answer the question yet. It said to solve it. So the solution, I can see on the graph, it only intersects at one point, and that is what I write for the solution. It was on both tables. And remember, you can also check this in your calculator by putting them in y equals and tracing the intersection, or looking at the table to make sure that the point you see here is the solution. So my solution is -2, 2. And this should seem familiar to you because if we look back at question number 1, this is the same question. We just solved it graphically instead of algebraically. And you can see it on the graph. The circle shows that this is the solution here. Okay, have a good night.